Okay, so what if I told you that a warm object, like the sun or even just a regular light bulb, could actually pull you closer? I know, it sounds completely impossible, right? Well, today we are diving into a theory that kicks off with that simple, kind of bizarre observation and ends up challenging the very foundations of modern physics.
So let's start with this question. Just let it sink in for a second. Can a warm object really pull things toward it? I mean, our intuition just screams no, right? Light and heat push, they don't pull. But what if a real world experiment proved our gut feeling was totally wrong?
And yeah, that is exactly what happened. Back in 2013, an experiment in Austria discovered that blackbody radiation, which is really just the fancy term for the light and heat that any warm object gives off, can exert an attractive force, a pull. And this pull even worked on neutral particles, which really shouldn't be affected like this. Now here's the real kicker. At lower temperatures, this mysterious pull is actually stronger than gravity. So you can see how this discovery created a genuine puzzle for physicists. How on earth do you explain an attractive force, a pull, coming from something we've always associated with energy pushing outwards?
Now, the standard explanation, it involves something called the Stark effect. And basically, that just means that particles change their energy state and are then drawn toward the light. But physicist Miles Mathis argues that's not a real explanation. It's just a description of what happens, not how it happens. What is the actual physical mechanism, the nuts and bolts of it, that's causing this pull?
To find that mechanical answer, this alternative theory says we have to go all the way back to square one and completely rethink the most fundamental particle of light itself, the photon. And this slide, it just lays out the two competing ideas perfectly. So on the left, you've got the standard model's photon. It's kind of this ghostly packet of energy. It has no mass, no charge, and physicists can basically just create or destroy it in their equations whenever they need to. But on the right, this new theory proposes a photon that's a real physical particle. It has mass, it has spin, it's not just some math trick, it's a tiny physical machine. And that brings us to the absolute heart of this theory, the charge field. I want you to forget the idea of empty space. This theory says the entire universe is filled with a sea of these real spinning photons. It's not a vacuum, it's a plenum, a space that is completely full of matter. And this field, it's the fundamental engine behind everything we see. Okay, so with this new model in our heads, a real photon and a universal charge field, let's go back and see how it claims to solve that initial puzzle of the mysterious attractive force. All right, here's the mechanical breakdown. First, just imagine that the charge field is constantly pushing everything apart. It's a baseline repulsion. Now that warm object, it emits its own photons. And if these new photons are spinning in the opposite direction of the field photons, kind of like two gears spinning against each other, they can cancel each other out. This cancellation creates this little calm zone with less energy between the objects. And with less repulsion pushing them apart, well, the objects are free to drift closer together. And this gets to the theory's most radical claim of all. There is no such thing as attraction. Not really. What we perceive as a pull is always just less push. It's an incredibly simple idea, and frankly, it's pretty mind-bending. But wait a minute. This attraction only works up to a certain point. At really high temperatures, it flips and becomes a repulsive force again. So why? Well, the theory says that as you add more and more heat, you're just cramming more and more photons into the same space. And eventually, the sheer number of photon collisions, just a raw physical pushing force, it overwhelms that subtle spin cancellation effect. The field just becomes too chaotic and dense for that less push trick to work anymore. Okay, so the theory offers a pretty neat explanation for one weird experiment. But this is where it goes from being a niche idea to a potential theory of everything. It claims this one concept, the charge field, can solve some of the biggest mysteries in all of physics. And it all starts with this one number, 95%. According to this theory, that's how much of our universe we've just been missing. 95% of all the mass and energy isn't in the stars or galaxies. It's hidden in plain sight, making up this fundamental charge field. So, this one number is proposed as a solution to two enormous mysteries. First, dark matter and dark energy. The theory says, nope, they don't exist. The 95% of missing stuff in the universe is just this charge field. And second, it explains a weird quirk of radiation. That leaves 5%, which is the baryonic matter. That's just the normal stuff like us, protons and neutrons, that can't be recycled as part of the field. And the list of claims just keeps on going. The theory suggests this charge field gives a mechanical reason for why heated objects glow infrared first. It explains that strange way things kind of jump in color from red to white instead of moving smoothly through the whole rainbow. It even proposes a mechanism for how photons under extreme pressure can actually stack their spins together to literally become electrons. I mean, each of these is a huge puzzle in physics, and this theory claims to have the master key. So, as you've probably figured out by now, this isn't just some minor tweak to existing physics. No, this is a fundamental, bottom-up challenge to the entire standard model. And this quote from the source really captures the heart of the critique. The argument is that by making the photon a massless, non-conserved particle, mainstream physics has basically created a fudge factor, a mathematical tool that can be pulled out of a hat to make the equations work, but without providing a real mechanical explanation for what's happening.
This table really brings it all home. The standard model says quantization, those weird little jumps in energy, happens at the level of the electron. This theory says no, it happens at the level of the photon itself, through its spin. The charge field goes from being just a mathematical convenience to being the most real thing in the entire universe. And the photon gets upgraded from a ghost in the machine to the machine itself.
Ultimately, exploring a theory like this, it isn't just about whether it's right or wrong. It leaves us with a much bigger question. How complete are our models of the universe, really? It's a reminder that there could be fundamental mechanical forces at play all around us, just waiting to be seen.